You're welcome to today's class. Today we are going to continue where we stopped in the last class, which is arrays, indices, memory addresses, and compiler mapping. So in this class, I'm going to use proper terminologies to explain an array. So today I will tell you that an array is what? Is a static linear data structure that is used to store multiple values of the same data type under a single variable name, right? So based on that definition, I will say that instead of saying int score 1, right, assign 10 to it, then int score 2, assign 20 to it, int score 3, assign 30 to it. We can say int scores 3, assign then this element 10, 20, 30, right? We can write it this way. So this is a proper array definition. So writing it this way will make program very easy to write and to understand, right? Now, based on this, we can now deduce the syntax of an array. This is a data type. I told you data type is like the nature of the array. So this is what? Data type. Now, this is the syntax. Array name, right? Then array size, right? And then element separated by commas. So this is the syntax of an array. Data type, array name, array size, and the elements, which are separated by what? By commas. Now, when you look at this, you look at, say, I write something like this. So this one, I'll put it here. This one, I'll put it here. And then this one, I'll put it here. Now, this is index 0, 1, 2. But often, many students usually confuse this index with what? Memory addresses. So, assuming here I have 104, 100, then here 104, and this place 108. Now, if you look at this data type, if it is an integer, for example, this is an integer. So this is an integer. An integer is what? 4 bytes. Right? 1 byte equals to what? 8 bits. That I have taught you in my previous classes. So if I'm having a physical memory address of 100 and I have an integer there, so it means it's 4 bytes. So what this is telling you is that this 10 is occupying 100 to what? 103. So that is what? For 10. Then the 20 is occupying 104 to what? 107. And then the 30 is occupying 108 to what? 111. These are all 4 bytes. That is what this is telling you. Now, the difference between this index and memory address, right? So this is a logical layer, and then this is a physical layer, right? But both are inside the RAM, which means inside the memory. So the programmer is dealing with what? The indices and what? The element. While the CPU is dealing with what? The actual memory address and what? Byte. The programmer doesn't have any business with byte, but the CPU doesn't have any business with index and what? Or indices and what? And the element. So what is actually being stored in the memory is what? 0 and 1. And that is what the CPU is going to see. So there is a person or there is a guy that is responsible for interpreting the language between the logical layer and the physical layer, and that is what? The compiler. So when an instruction is given for you to access a particular index, say index 2. So when you write something like this, when you write scores 2, meaning you are asked to pull out the element that is in this index, what the compiler will simply do is that the compiler will use a formula, a rule, to find the element in the actual physical location. So to achieve that, the compiler will do memory address equals to what? Base address, right, plus offset, where this offset equals to um, index multiplied by what? Size of data type. Size of data type. So this offset is talking about the positional location of the elements. That is what this offset is all about. And that is why we are using this index. So the question you will ask is that, why are we starting the index at 0 instead of 1? Because of this mathematical equation. So what the compiler does, when you ask the compiler to locate the actual memory address of the element in this index, which is what? The third element, is that the compiler will find memory address, MA, equals to base address. So the base address of this array is what? 100. 100 plus offset, which is what? Index multiplied by size of. So index is what? 2. Multiplied by size of data type is what? 4. Meaning integer. Integer is 4 bytes, right? 4 bytes. So that will give us 100 plus 2 times 4, that is 8. So that will give us 108. So which is this? You can see it. That is the starting address. Then it will now count 4 bytes as the complete physical location. So when a plane is flying, this is the mathematics that is being done, but in a complex format, because that one has to do with what? Multiple dimensional array. But this is the concept, that the programmer is dealing with the element. So the element, the indices is mapped to what? Element at the logical layer level in which the programmer is existing, while memory address is mapped to what? Byte, which is the actual physical location where the element is going to reside. But it has to be converted to 0 and 1, right? Before it can be stored in that location. So the CPU, the compiler, converts this instruction at this level to this for the CPU to act, right? So this is the concept of an array. An array then can be defined as a collection of elements of the same data type stored in a contiguous memory location and accessed using index, right? That is the definition. So that is what I want to show you. Now, another thing again you have to observe in this is what? The array name is a pointer to the base address of the first element. An array name is a pointer to the first address, to the base address of the first element. So when we are saying int scores, right? This scores is the same thing as address of, right? Scores 0. meaning it's pointing to the address of scores 0, which is what? The base address. So when we say scores plus 1, what we are simply saying is what? We are saying 100 plus 4 equals to what? 104. So this is known as pointer arithmetic. So when we say scores plus 2, this is the same thing as saying 100 plus 8, which is what? 108. So this is pointer arithmetic. It's not just this 2 or 1 is not actual 1 or actual 2. We are looking at what? The byte. Right? So that's what I want to show you in the class of array. That array has 2 layers, which is the logical layer and the physical layer. In the logical layer, in which the programmer is dealing with, we have index mapped to what? Element. In the physical layer, we have memory address mapped to what? Byte. Then it is the responsibility of the compiler to now map this index to what? To the actual memory address in order to pull out the element that is existing in that location. So that is what we are saying here. So I told you 10 will now carry from 100 to what? 103. 20 will carry from 104 to 107. And 30 will carry from 108 to what? 11. Right? Which is what? The actual memory address in the memory. But both the logical and the physical take place inside the RAM. So you need to understand that and differentiate both the index and the memory address. So this is what I want to show you in this class of array, right? So there are rules in which the compiler is using to map this index to actual memory address. So every company that wants to scale, there has to be a rule behind the scene that we are following. So that is what I want to show you in this class. So the next class, I'm going to show you some of the operations that can be carried out on an array as a data structure. So if you look at this, assuming I have this 20 here and I have this 10 here, then I want to rearrange it, right? So sorting, I want to bring this here and bring this here. What is the algorithm that will be used to achieve that? And again, the time required to access this element and the time required to access this element and the time required to access this element are constant. So that will give us 0, 1. So time complexity is what? Is a constant time. That is big O notation 1. Based on this formula, the time I will need to access this element and to access this element is the same. So even if I have 1 million elements, the time to access the first element and the time to access the last element at the same time. That is where array is important or is useful in searching, right? So, but when you have to sort, then the complexity is now different. I will now look for what? Other data structures. So that is what I want to show you in this class. If you have come with me this far, don't forget to give me a thumbs up. And if you have not subscribed to my channel, please do so in order to encourage me. So till we see in the next class. Bye-bye.